Hello everyone. On this video we will be looking at different strategies for finding limits. Okay, so if you remember on previous videos, the first thing you always want to try is direct substitution. Just plug the value right in, see if the limit can exist. But if it doesn't, these are a few things you can try to help you find the limit. Okay, so first thing we're going to do is try rationalizing the numerator or denominator. The numerator or denominator. Okay, now these are mostly useful if you have any kind of a square root in your numerator or denominator. It helps get rid of it, or at least move it somewhere else. Okay, so let me give you a quick example of what I mean by that. What if we wanted to find the limit as x approaches 0 of square root of x plus 1 minus 1 over x. Okay, now we can see here that we can't plug in 0 because you have square root of 0 plus 1 is just square root of 1, so 1 minus 1 is 0 over 0, 0 over 0 is indeterminate. We can't do anything with that one. Alright, so we're going to rationalize the numerator and or denominator. Now to do that, you have to remember the conjugate of square root of x plus 1 minus 1 is square root of x plus 1 plus 1. Excuse me. Okay, remember, to find the conjugate, you're just changing the sign between the root value and the constant. Okay, so we change that from minus to plus. Okay, and we multiply our function by the conjugate over itself. And I'll show you what I mean by that. Okay, so that means, just going to write that down again, the limit as x approaches 0 of square root of x plus 1 minus 1 over x. Kind of draw a little separator here. We're going to multiply this by its conjugate, square root of x plus 1 plus 1 over square root of x plus 1 plus 1. Okay, remember, we're multiplying it over the same thing because technically that's just multiplying it by 1. Okay, so if we go ahead and FOIL these out, let me make sure that looks like a minus. I kind of tried to fill it in and made it look different, so minus 1. There we go. Don't want any confusion there. Okay, so if we FOIL this out, that will give us the limit as x approaches 0. The square root of x plus 1 times the square root of x plus 1. You get basically a square root squared, which is just 1, so that gives us x plus 1. Then you have plus square root of x plus 1 minus square root of x plus 1, which cancel each other out, so the outer and inner cancels out. So you have your last, which is just minus 1. Okay, so if you want, just as a reminder, you could just put those in parentheses and then just FOIL. Okay, so once you FOIL it out and cancel out your outer and inner, this is what you end up with. All over x times the square root of x plus 1 plus 1. Okay, so the denominator, I just kind of multiplied those together. Okay, so since this is positive, you can remove the parentheses, so you have x plus 1 minus 1. But really, these two just kind of cancel each other out. So you end up with the limit as x approaches 0 of x over x times the square root of x plus 1. Uh-oh, clean that up a little bit. X plus 1 plus 1. Okay, that's the reason I didn't distribute that. Because this way, those two can cancel out. Okay, so these two go ahead and cancel out. That leaves us with the limit as x approaches 0 of 1 over square root of x plus 1 plus 1. Okay, so you have the very same function you started off with. You just kind of manipulated it a little bit. Now what do? Now use direct substitution. Okay, now if you plug in your x equals 0, you end up with 1 over 0 plus 1 is 1, so square root of 1 is 1. Square root of 1 plus 1, which is just 1/2. But as long as x doesn't equal 0. Okay. Now even though we manipulated it a little bit, your x still can't equal 0 because in the original form that would give you a denominator of 0. Okay, but we do know that the limit will be 1/2. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Alright, so let's say, for example, if you wanted to find the limit for, let's say, the limit as x approaches -3 of x squared plus x minus 6 all over x plus 3. Alright, so I'm just going to go ahead and remember, first thing you always want to try is direct substitution. But you see here, if you plug in -3 for x, you get a denominator of -3 plus 3, which is 0. So you can't have a denominator of 0, so you can't just plug it in using direct substitution. But you are never ever wrong for having that be your very first step. Always try direct substitution first. Okay, it can save you a whole lot of work. Okay, so if you have the limit as x approaches -3 of x squared plus x minus 6 over x plus 3, well, if you see here, this kind of looks like you can do something with this numerator here. So what we're going to do is we're going to factor that numerator. Okay, so that gives you the limit as x approaches -3 of x plus 3 times x minus 2 all over x plus 3. Okay, now just a heads up that you do have to write the limit each time. You can't just go limit this, okay, I'm just going to write it this. If you just leave out the limit and write this here. You can't do that. That's a good way to probably lose points on a test. Okay, so definitely write the limit each time. It may feel like a bit of a pain and unnecessary, but trust me, I've lost plenty of points as a student failing to write that limit down. So I don't want you to lose points on exams, so be sure to write limit down. Okay, so you see these two will cancel out, which leaves you with the limit as x approaches -3 of x minus 2 over 1, which is just x minus 2. Okay, now if you just go ahead and plug in your -3 now, using direct substitution, that will give you a limit of -5, given that x does not equal -3. Because remember, x can't equal -3 up here. Okay, but you do have a limit of -5. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so what if we wanted to find the limit? We have the limit as x approaches 0 of x minus 4 squared minus 16 all over -2x. All right. So looking at this, again, if you immediately try direct substitution, you'll see that it'll give you a denominator of 0. So you can't do that. Okay. Now, if you notice here, this is a difference of squares. It will give you, let's look at a squared minus b squared, a plus b, a minus b. Okay, so you could use the difference of squares if you make that x minus 4 squared minus 4 squared. But what we're going to do is instead we're going to just go ahead and expand that and FOIL it out. Okay, but if you chose to use the difference of squares for that numerator, you wouldn't be wrong. Okay, so let's say if we have the limit as x approaches 0 of x minus 4 squared minus 16 all over -2x. We're going to go ahead and expand this out right here. So that will be x minus 4 times x minus 4. Just a little side note here. X minus 4 squared. We're going to make that x minus 4 times x minus 4. So if we go ahead and FOIL it out, we end up with x squared minus 8x plus 16. Okay, so that means you have the limit as x approaches 0. This just becomes x squared minus 8x plus 16. X squared minus 8x plus 16 minus 16. Can't forget that minus 16 there. All over -2x. Alright, so you see that since it's positive, you can go ahead and drop the parentheses here. But these two will cancel each other out. So you have the limit as x approaches 0 of x squared minus 8x all over -2x. Okay, now you still can't plug in 0, but you can factor out an x. So you have the limit as x approaches 0. Yes, remember, write it every single time. Of x times x minus 8 all over negative 2x. Where now these two will cancel each other out. You have the limit as x approaches 0 of x minus 8 over negative 2. Where now we can go ahead and just plug it in. Move that up a little bit. Direct substitution. Alright, so if we go ahead and plug that in, we end up with 0 minus 8 over negative 2, or just negative 8 over negative 2, which is 4. But we still know that x can't equal 0 because where we started. Okay, so sometimes you do have to kind of manipulate your function in order to find the limit. Alright, so hopefully this made sense, and I will see you on the next video.